Hello students, welcome back to my channel Positron. Dear students, I'm making the videos on the first chapter of 11, that is electric field and charge. My first video that I have made was based on the charge method of charging, properties of charge. Second video was based on Coulomb's law in vector form, principle of superposition and electric field intensity. Third video was electric field intensity, electric field lines, their properties. Today's topic is electric dipole. Dear students, on the basis of conductivity, on the basis of charge, on the basis of electricity, the particles can be divided. Actually, one thing I'd like to tell you all, today's we are studying actually that properties of the charge, where charge is static. Actually, this all topic is based on electrostatics. Electrostatics means what the property charge reflect when it is at rest. Means a rest charge, what can it do? What is the nature of a charge when it is at rest? All that is studied in electrostatics. So we are studying electrostatics. Dear students, molecules on the basis of polarity, on the basis of dipole, the molecules are divided into two types. First one is a polar molecule and second one is a non-polar molecule. Now, dear students, what I said, the molecules are divided into two types. One is a polar molecule and there is a non-polar molecule. What is the first? We will discuss that. What is the non-polar molecules? We are considering those molecules which are having odd number of atoms. They are composition of even number of atoms, even type of atom. For example, considering H2, O2, N2. Right? If you consider H2, hydrogen has three isotopes. One is a N1H1, second one is a 1S2, third one is a 1S3. First one, isotopes are what? Isotopes are those atoms which are having the same atomic number but the different mass number. These are said to be the isotopes. Hydrogen has three isotopes. 1H1, 1S2, 1S3. 1H1 is a protium, 1S2 is a deuterium, 1S3 is a tritium. 1H1 is the maximum that is found in nature. This is less found, less probable, and 1S3 is the rarest found, that it has a very less percent, even less than the 1% of total hydrogen found on the earth. Dear students, 1S2 is a very famous D2O, that is a heavy water used as a moderator in nuclear reactor. Moderator means the material which is used to slow down the speed of nucleus is said to be the moderator, and water molecules, heavy water molecules, D2O, that is expressed as, and that is used as a moderator in nuclear reactor. Now, dear students, let's come back to our topic, that I'm trying to explain the non-polar molecules. H2 on O2 N2. Hydrogen has atomic number 1, so that is 1 electron and that will live in the first orbit. Oxygen, oxygen you express 8O16, that is a atomic number is 8, means its electronic configuration is 2,6. The outermost orbit is consisting 6 electrons, and that is a lack of 2 electrons to complete the octet. That is deficiency of 2 electrons to complete the octet. Then is a nitrogen. Nitrogen is 7 and 14. It is a 2,5. Means the electronic configuration of nitrogen is a 2,5. It is lack of 3 electrons to complete the octet. In case of hydrogen, there is a one and only one electron that will reside in the first orbit, and you know that first orbit, to complete the first orbit, it needs only 2 electrons, so it is a lack of 1 electron. If it will get 1 electron from anywhere, it will just become a stable, like helium. Helium is a 2He4, that is a neutral gas, you know. Now, dear students, for example, if you are considering oxygen, in the oxygen, their electronic configuration is 2,6. They are lack of 2 electrons. So these two oxygens in the oxygen molecule will share 2 electrons each, and that is why there will be double bond between them. But at both the sides of bond, there is same oxygen atom and means same electronegative atom, so the electron will occupy just at the mid. The shared electron will reside just at the mid of this OO bond, and that is why no any atom will attain any polarity, attain any charge. That is why this is a non-polar molecule. Non-polar molecules are those in which the shared electron resides just at the mid of the bond. That is why no any atom will attain a charge, no any atom will get polarized. For example, in the nitrogen, that is N333, right? They will share undoubtedly 2,5. So they are lack of 3 electron to complete the octet, so that they will share 3 electron to each other to complete the bond, and that 3 electron must will reside just at the mid of shared bond. In the similar way, oxygen, you can say same explanation. Now, dear student, this is said to be the non-polar molecule. Now, what is the polar molecule? Polar molecule is a, for example, consider H2O, right? In H2O, what I am considering, this is O, and H needs 1 electron, right, to complete to get the stability. So it will share 1 electron with the oxygen, and this hydrogen again will share 1 electron with this oxygen. So what happens? Dear students, so now in this case, oxygen is more electronegative, so the shared electron will be attracted towards oxygen. So oxygen acquires some negative, partially negative, and another one hydrogen becomes partially positive. Now just shared electron, a bit has been replaced, a bit has been attracted towards the more electronegative oxygen. And that is why what happens, that it gets some negative charge, whereas this gets some positive charge. In this way, this H2O molecule has been polarized. So the two kind of molecules are there. Now look here, this polarity happens when there is an odd kind of molecule combining. The odd kind of atoms are combining to form the molecule, and in that case the shared electron will be displaced towards, will be attracted towards more electronegative, so it is called to be the polar molecules. Now dear students, very important thing, today's topic is electric dipole. That is why I am discussing with you the polarity, what is the polar molecule, what is the non-polar molecule, and what is the electric dipole. Now important is to discuss that what is the electric dipole. Dear students, electric dipole is a system which is consisting two charges equal in magnitude, opposite in nature, kept at a little distance from each other. Now look here, it is a combining the two charges, plus q and minus q. This distance I am considering 2L. 2L or 2A, whatever you want. What I have said, that what is electric dipole, how will you define the electric dipole? It is the composition of two charges equal in magnitude, opposite in nature, and are being separated by a little distance with each other. This distance is in order of angstrom, so such a composition is called to be the electric dipole. Dear students, why we are considering 2L, why don't we consider L? Simply because so much calculations you have to do further in order to find out the field and potential. That is why we consider 2L, because most of the time you have to consider the half of that distance. So if you consider 2L, half of it will become L, or you might can take L, there is no problem at all, right? So now important factor here is to define the dipole moment, right? Dipole moment is a what? Dipole moment is a vector quantity, and it is defined as any one charge multiplied by the distance between the two charges. Dipole is what? It is a composition of two charges equal in magnitude, opposite in nature, kept at a little distance from each other. Such a composition is called to be the electric dipole. And dipole moment is a one charge multiplied by the distance between the two charges, that is said to be the dipole moment, and P is equal to Q into 2L. Dear students, when I was discussing the dimension, when I was making the videos on dimension analysis, I have told you all that there is no need to mug up to learn so many dimensions at the very time, because as you will move further, as we will move ahead, so many new physical quantities we will be familiar with them, and at the very moment we should discuss their unit and dimension. So this is a time to discuss the unit of dipole moment. Q is a coulomb, very simple, and 2L is a distance between the two charges, undoubtedly it's a meter. So it is a coulomb into meter. This is the unit of dipole moment, and the dimension of dipole moment, very simple. Q is not a fundamental quantity. Fundamental quantity is what? Electric current. I is equal to Q upon T. Rate of flow of charge is called to be the current. So Q is equal to I into T. So this is Q might be written as AT. In terms of dimensions, 2L is a L. So this is ATL. Dear students, dipole moment has the dimension ATL, right? So I'm moving ahead. What I have discussed here, I have discussed that there are the two kind of molecules. So one is a polar and there is a non-polar. Non-polar molecules. First I have discussed non-polars are what? Those molecules which are composition of even type of atoms. Then the shared molecule will reside just at the mid of the bond. That is why no anyone will acquire any kind of, will be polarized. But in the case of polar molecule, there is a odd kind of atoms are combining to form the molecule. In that case, the shared electron will be attracted towards a more electronegative, as I have given you the example of S2O. There are many examples like CCl, for so many carbon sulfide might be, I think. So many examples are there. Yes, this is polar and non-polar molecule are very important when we will study the capacitance. When I will discuss the capacitor about with you all, then at that moment we will discuss that what is the importance of polar molecules or non-polar molecules when they are filled between the two plates of capacitor. Now dear students, today's topic is electric dipole. So I am bringing you back on the electric dipole. I have discussed with you all electric dipole. That is a composition of two charges equal in magnitude, opposite in nature, kept at a little distance from each other. That is said to be, that kind of composition is said to be the electric dipole. And electric dipole moment is what? A charge multiplied by distance between the two charges is said to be the electric dipole moment. Its a unit is a coulomb into meter and dimension is undoubtedly ATL. Now we have to find out the field, electric field due to electric dipole. Field due to electric dipole. There are two cases. First case, when the point is existing on the axis, on the line joining the two charges, that is said to be the axial position or end-on position. And second one is when the point is existing at the perpendicular bisector of the two charges, and that is said to be the broadside down position or equatorial position. So case first is a when point is existing, point is lying on axial position. Very simple, nothing you have to do, just you can solve it. It's a matter of minute. Now what I have made? I have made a dipole plus q minus q. They are 2L distance apart, right? This is the center of the dipole, so it is a L, this is a L. And from center of the dipole on the line joining the two charges, there is a point P, which is smaller distance away from the center of the dipole. Now we have to find out the field at point P. Dear students, what I have done, I have considered a dipole. This is plus q minus q, 2L distance apart. This is center of dipole. It is 2L, so it is a L. It is a L. From center of the dipole, point P is existing at a smaller distance away at the line joining the two charges. That is why it is called to be the axial position. Now, this distance will be what? This one is a R, this one is a L, so it is a R minus L. Again, this one is a R, this one is a L, so from here to here, R plus L. Now, dear students, I am just repeating my words, what I have said when I was discussing with you all about the electric field, that whenever you have to find out the electric field intensity at any point, just consider the positive test charge placed there, or just imagine the positive test charge kept there. Now, if you consider a positive test charge here, then this positive charge will repel this in this way, that becomes E1, and this negative charge will attract this charge E2 in this way. This is the E2. It means the net field at point P will be E1 minus E2 or E2 minus E1. Which one is a bigger? We just have to subtract the smaller one. So net field at point P, that is equal to E1. This sign means I'm subtracting the smaller one from bigger one. Either it is E1 minus E2 or E2 minus E1. Now, dear students, what is E1? E1, just I'm considering only the magnitude, because only first we have to find out the magnitude. E1 is equal to, E1 is a field due to that one, that is 1 upon 4 pi epsilon, applying the Coulomb's law, charge is a Q, upon distance of point from the charge, that is R plus L whole square. And now E2 is the field at point P due to charge minus Q. Now it is a 1 upon 4 pi epsilon naught Q upon this distance. Distance of point from the very charge you are considering. This is R minus L. Q upon R minus L whole square. Now look here, dear students. You might say that why I have not considered here minus Q, because the minus Q has came into the direction, because of plus Q that the field is this direction, and because of minus Q it will attract the positive test charge, so field is this. That is why in this direction of E1 and E2 the minus Q plus Q has just came into the formula, so there is no need to keep minus here, right? Now, dear students, if you compare this, Q upon 4 pi epsilon naught is the same. This is 1 upon R minus L square. This is R plus L square. So this one is a bigger than this. So E is equal to E2 minus E1. Now it becomes 1 upon 4 pi epsilon naught Q upon R minus L whole square minus 1 upon 4 pi epsilon naught Q upon R plus L whole square. Now, dear students, I am just writing down here. So it is E is equal to, now look here, Q upon 4 pi epsilon naught I'm taking out. So it is a, now here will be, you will be left R minus L whole square into R plus L whole square. And so if you will divide this term by R minus L whole square, you will be left here R plus L whole square and then minus R minus L whole square. Divide this term by R plus L whole square, so you will be left with R minus L whole square, multiply by 1, you will get that. Now dear student, this is A minus B whole square, A plus B whole square. You can write A minus B into A plus B whole square, common power, common square. And A minus B into A plus B turn out to be A square minus B square. So this term you might write like this, Q is equal to Q upon 4 pi epsilon naught. This is R square minus L square whole square, right? A minus B into A plus B, that is R square minus L square, and now common power is A square, just I kept here. Now dear student, A square plus B square plus 2AB 2RL minus this is R square minus L square. You have to open this. It is actually R square plus L square minus 2RL. When you will open this bracket, minus R square minus L square plus 2RL. So plus 2, R square plus L square will be cancelled both in both the terms, and it is 2RL plus 2RL, that is 4RL. Now it becomes E is equal to Q upon 4 pi 1 upon 4 pi epsilon naught. Now look here, Q into 2L I am taking in this way, Q into 2L, 2 I am taking here into R. If you look here, Q into 2 to the 4 LR, right? Q into 4 LR. So nothing I have done different. Now it is R square minus L square whole square. Dear students, 2L is the distance between the two charges in the dipole. That is a distance in the order of angstrom, right? And now point P is a smaller distance away, right? And small r is a, P is a point of your choice. Your choice cannot be below the millimeters. You cannot imagine a point that is just 2 microns or 3 angstrom away from you. You will consider a point 2 millimeter, 3 millimeter, 1 centimeter away from the charge. So small r is a distance of a point of your choice, right? That is much bigger than the L. So R is greater and greater than L. That is what happens here. Now neglect the L here, but do not neglect here. If you will neglect here, L means become 0. So this term vanishes. That is why you just have to neglect the L, small l in the denominator only. So you will get E is equal to 1 upon 4 pi epsilon naught. Dear students, Q into 2L is a P, 2PR upon, if you will neglect, you are neglecting small l, so it turns out to be R square whole square, that is R to the power 4, it will be cancelled, R cube. So result that you have got in axial position EA, that is representing the electric field due to dipole in the axial position, EA is equal to 1 upon 4 pi epsilon naught 2P upon R cube. This is the value of electric field in the axial position. Axial position is what? When the point is lying on the line joining the two charges, that is said to be the axial position. There's, I'm very sure you will be following. If you have a problem, do comment me. I must try to remove all that confusions. Now, let's move further. Case 2, that is in broadside on position. In equatorial, that is very familiar word, equatorial position. Now, dear students, what we have to do? We have to find out the field due to a point existing on the equatorial position. Equatorial position is what? When the point is a point is existing on the perpendicular bisector of the two charges. Look here. Dear student, the two charges are here, plus q, minus q. They are 2L distance apart. This is their center, so it is L, it is a L, and this is the perpendicular bisector. Here I am considering the point P, right? It is R, this point P is a smaller distance away from the center C, so it will be under root R square plus L square, and the similar way it is R, it is L, from the Pythagoras, this will be under square root R square plus L square. Now, dear students, where the basic concept is, in order to find out the field at any point, what you have to do, you just have to consider a positive test charge there. So first we will consider a positive test charge here. This charge will repel this positive test charge in this way. Let this is E1, and this negative charge will attract this one, that is the E2. Dear students, sometimes we get confused that what is the force or field here due to this. No, that is not our condition here. What we have to do here, we just have to find out the field at point P due to these charges. So we have to consider the impact of these charges here, right? Rather to consider the impact of this charge at this very point, right? So what is the force acting on these charges due to this positive test charge? We have assumed at point P, no matter to consider, right? So we have to find out the field at point P. What I have done first, very first, I have imagined a positive test charge here. This charge will repel this positive test charge along the line joining the two charges in this way. How? Along the line joining the two charges in this way. This is like E1, right? And this negative charge will attract this test charge along the line joining, that is E2. Now, dear students, E is equal to what? 1 upon 4 pi epsilon naught Q upon R square. So, field due to plus Q at point P, 1 upon 4 pi epsilon naught Q upon the square of this very distance. And in similar way, the field at point P due to minus Q, that is a 1 upon 4 pi epsilon naught Q upon square of this distance. So it is clear that E1 and E2 are equal in magnitude. So mod of vector E1 means E1 is a vector quantity of which we are concerned only with the magnitude at this very time, and that is equal to mod of E2, and that is E. Suppose this will make the calculation very easy. That's why I am making. This angle, let it is theta, this is one is theta. Now, I am just drawing a line parallel to this line, right? Let it is AB. So, parallel, I have drawn a line joining point P parallel to AB. If this angle is theta, then this is the adjacent angle and will be theta, adjacent or whatever set, right? If this one is theta, then this is this one will be theta, right? What is called to be that is what I have said, but that is if these are the two lines, this theta, then this theta, and this theta, then this theta, opposite angle you can say in this case. Now look here, dear students. Now what we have to do? So it is a E, and this is also E. One thing is very important that you have to remember to solve such a problems. Look here, let it is vector R, this is theta, and this is the perpendicular component. I am considering the two perpendicular components of vector R. Dear students, if this angle is theta, if you consider cos theta in this triangle, then you will get here R cos theta, and it is R sin theta. What I am requesting that all the time you have not to consider the triangle, just directly you have to put the values. Now look here, this angle is theta. So the component close to the adjacent to the angle is a cos, and perpendicular component away from the angle is a sine. Simply, if this angle is theta, then this is the cos theta and this is the sine theta. So that component which is close adjacent to the angle, that is cos, and the component away from the angle, that is sine. Now dear students, look here. For E, this is close adjacent to the angle, so it is a E cos theta. That is E cos theta is a component of E along this line, and this is E sin theta away from the angle. Now dear student, E sin theta away from the angle. Now dear student, this one is E, so this is close to the angle, again it is E cos theta, and another one, this is a perpendicular component, E sin theta. Now look here, the y components are equal and opposite, so Ey is equal to E cos theta minus E cos theta, that is 0. Now net field is what? En, if the two components you have got anyhow, that is Ex, Ey, then net component En equal to under root Ex square, En equal to under root Ex square plus Ey square. Now look here, if Ey is 0, net component along y is 0, then En equal to square root Ex square, that is Ex, and if Ex is equal to 0, then square root En is equal to square root Ey square, that is Ey. Means, in this case, dear student, y component is 0, so net field is only along x axis. You can write En is equal to, that is E cos theta plus E cos theta, that is 2E cos theta. Now E is a what? 2, 1 upon 4 pi epsilon naught Q upon square of that much, that is R square plus L square. Now dear student, cos theta is a base upon hypo, so L upon square root R square plus L square. Now it becomes 1 upon 4 pi epsilon naught Q into 2L over R square plus L square to the power 3 by 2. Now dear student, this is the net field at point P, and you know Q into 2L is what? Again, that is a P, and R square plus L square to the power 3 by 2. Again, I am just making the same approximation that I have done in the last article, that R is greater and greater than L. So neglect L here, but not in the numerator, because if you neglect the L in the numerator, that will vanish, that will become, the total quantity will become 0. So neglect here L, it is R square to the power 3 by 2. R square to the power 3 by 2, if you will open, it turns out to be R cube. So this is a P upon R cube. Now dear student, this you can write it, this is a, in the equatorial position, equatorial position is a 1 upon 4 pi epsilon naught P over R cube. Now dear students, when you find out the field in axial position, that works out to be 1 upon 4 pi epsilon naught 2p upon r cube, but in case of equatorial position, it works out to be 1 upon 4 pi epsilon naught p upon r cube. If you divide these two, very interesting, you will get E axial over E equatorial, that is equal to 2. Rest of the things are same. This is just 1 upon 4 pi epsilon naught 2p upon r cube, and another is 1 upon 4 pi epsilon naught p upon r cube. It means E axial is equal to 2 into E cube. Means in the axial, the field is a 2 times of the equatorial field. Least but not last, I tried my best to explain the topic going on. Dear students, I hope that you people would be following to me, and I am making a request from very deep and sincere of my heart, that if you think that my videos are going to be beneficial to you, then please and please like, comment, share and subscribe, and must put the bell icon so that you might be notified about my next video. Meet you in next video. Thank you. Bye.